Hi guys, this is Ms. Miner, and this is lesson 3D. And our goal for this lesson is to be able to use inputs to predict a future output from a real world and linear function. Okay, so remember, real world is a story problem or an example that you might find out in the real world. And the word linear, remember, means... Oh, now I'm done it. The word linear means a line, a straight line, right? So this is an equation, a linear equation or a linear function creates a straight line on a graph. And we kind of talked about this or learned about this last time. So let's kind of, actually, I want to do this. I want to split screen this. And I want to go to here. Okay, so we have some story problems here, and we're going to graph them, and we're going to see what we get. Okay, so the first one is up here, and it says, John has $30 and doesn't save any money. So if he's not saving any money, then his remember, is going to be $0. We're talking about money per week, and he starts out with $30. So we're putting in these numbers into equations. So there's John. Allison has $10. So she starts out with $10 and she saves $10 each week. Carrie has $20 to start out and saves $2.50 each week. And Bill has no money to start out, but saves $5 each week. So I hope that you're getting really good at writing out these equations, y equals blank x per plus blank, and that you guys are kind of figuring out where these numbers go. So these are just some easy real world examples. So what are we graphing here? Let's try and decide. So we're saving money each week, per week, right? And so per what? X is our number of weeks. So on our x-axis, we're going to be graphing weeks down here. And that should make sense because remember, Ms. Miner said that anytime I have some amount of time, it's always going to be graphed on my x-axis. Any amount of time, weeks, months, days, years, seconds, hours, any of those amounts of time, if I have that, time is very, very independent, and X is our independent variable. And I don't have a lot of control over time going by. I can't make time go by faster or slower or differently. And so if I have any measurement of time, that's going to be graphed on my x-axis because my x represents my independent variable. And so that means that my y has to be total dollars that I've saved. So y is going to be my total number of dollars. So what this equation is telling me right now is that my total dollars saved is going to be equal to the amount that I save every week, right? Plus whatever my starting amount would be. These are my starting dollars, okay? So when you start looking at this equation, I want you to do stuff like this where you kind of tell yourself what each part of this equation is saying to you, right? What does each piece of this equation represent? That's where we want to go. That's what we want to get good at. So X is my number of weeks. Y is my number of dollars. Total dollars saved. So now I've got to be able to graph these. So what Ms. Miner does is makes an XY table, and I choose some inputs, some numbers I'm going to put into my equation in order to get an output, right? And my input is going to be some number of weeks. My output is going to be my total dollars saved. That's what we decided. And that's what we're going to graph. So for each one of these, we're going to graph some inputs and outputs. So for John, let's do John first. This will be John's data. Let's choose a number to start with. And Ms. Miner always chooses 0 as the first number. Always, because 0 is super easy to calculate. It's also going to tell me exactly where my graph starts on the y-axis. So let's put a 0 in here for X. right? So now I'm taking John's equation, y equals 0x plus 30, and I'm going to input a 0 right in there for x. So I'm saying if no time has gone by and I haven't saved any dollars yet, no weeks have gone by, how many total dollars does John start with? Well, he starts with $30 because 0 times 0, if we input a 0 there, right, would be $0, and I would just have the 30 that I started with. Well, what if one week went by? What would I have if I had 1 week going by and I didn't save any dollars, right? If I had $0, I wasn't saving any more dollars, and 1 week went by, right? What would my total be? Well, it'd still be $30. What if 2 weeks went by? Well, of course, it would still be $30. And so I could come over here and I could graph John's data. At 0 weeks, he has $30. At 1 week, he has $30, right? At 2 weeks, at 3 weeks. Oh, sorry, 2 weeks is way over here. Now I've done it. Right? At 3 weeks, he still has $0. So John's line, oh, I've still got my highlighter pen. Come on, John's line. John's line is going to look something like that. Okay. And we're going to do this for each one of these people. Now let's go ahead and I'm going to switch colors over here. And we're going to do the same thing, but this time we're going to make a little XY table in order to be able to graph Allison's money saved. And Allison's equation was y equals 10x plus 10. And so I'm going to choose some inputs. And remember, Ms. Miner always chooses 0, right? If I take this equation and I input a 0, then my y amount is going to be 10. 10 times 0 is 0, plus 10 is 10. What if I input a 1? What if 1 week goes by? How many dollars will I have? Well, I will have $20 because I'll have my initial 10 plus 10 more from the first week. What if 2 weeks goes by? Well, I'm going to have $30 because every week that goes by, I'm increasing by 10 more dollars. So hopefully this is kind of starting to make a little bit of sense here. And so if I were to graph Allison, let's just label some of these. Let's label this as John. I'm going to put a J over here for John's line. And then I'm going to graph Allison in green. And so starting out, Allison had $10 before any weeks had gone by at 0, right? Here's 0. Then at 1 week, Allison had $20. At 2 weeks, Allison had $30. So Allison's line looks like that. Okay, so there's Allison. We'll put an A for Allison. All right, and then we want to do the same thing for Carrie. Here's Carrie's XY table. This will be for Carrie. And his equation is y equals 250 x plus 20. And at 0 weeks, he would have $20. Instead of doing by ones, because I have a 50 in here, let's go straight to 2 weeks. At 2 weeks, I would have a 2 in here, right? And so that would be $25. And then I'm going to go up to 4 weeks, and I'm using 2 multiples of 2 because I really like to graph with whole numbers, and I can see that's 50 cents. And so I want to have, whole dollar amounts. That's easy to graph. I don't want to have to graph a decimal or a fraction. So I'm kind of choosing multiples of 2 this time so that I get whole numbers coming out. And if I put now my input is a 4 over here, right? Then I am going to end up with $10 plus the $20, so that'll be 30. Okay, and that should kind of make sense, right? I'm increasing over here by $5 every 2 weeks that goes by. So Carrie's line starts out with $20 up here, right? And then on the second week, Carrie has $25. And on the fourth week, he has $30. And so his line looks kind of like this. There is C for Carrie. And right now we're just collecting some data and we're going to make some connections here in just a minute. The last one we have to graph then is going to be Bill. So let's get Bill's data. I'm going to extend this down just a little bit. And Bill's equation was y equals 5x. And he starts out with no money. So at week 0, he has $0, right? If I input a 0 here, right, then that tells me his starting amount. That's why I usually use 0. What about after 1 week? 1 week, he would have $5. After 2 weeks, he would have $10. So now I have some data I can graph. I'm going to come over here, and when he starts out, he has $0. After 1 week, he has $5. After 2 weeks, he has $10. And so we can start to see that Carrie's line then looks like that. Or sorry, this was Bill. B for Bill. Okay. So there's all of our people, and we have figured out how to graph their data. Now we want to go back. There we go. That's what we wanted. Okay. Sorry, that took me a minute to figure out. Now we want to answer some of these questions. We're going to make some comparisons about these graphs that we have. Which person starts out with the most money? So, and then we want to highlight this in each equation. I want to figure out, where is it telling me in my equation what the starting amount would be? And then how could I find that on a graph? So maybe right now pause the video and see if you can go through and answer these questions over here on the side. They're in your notes. And get those answered first, and then come back to the video and see how you did. Okay, so I hope you paused the video and tried this out for yourself. We're going to see which person starts with the most money. Well, remember, on my graph, it tells me right here at 0 weeks, each of these points that's right here on the 0, the y-axis at x equals 0, each of those points on the y-axis tells me their starting amount of money. So who had the most money starting out? Well, it was John, right? If I'm looking here, John had the highest money starting out. Well, now let's compare it in the equation. Where do I see these numbers? 30, 20, 10, right? Where do I see 0? This one over here is at 0. So where do I see these numbers in the equation? Oh my gosh, oh my heck, oh my gosh. It's the second number in the equation. It's my starting amount. That's why we call this like the starting value or the upfront cost or the fee, right? In my equation, that number represents the starting place on my graph. It's that place on the y-axis that's kind of starts is the initial value of my graph. Okay. Which person saves the most each week? So we're going to highlight it in the equation. And then also we want to look at the graph and trying to decide how could I tell from the graph which person was saving the most every week? So pause the video right now, try and answer this question on your own, and then come back and check your work and see how you did. Okay, hopefully you paused the video and tried this on your own. Which person saves the most every week? Well, if we're looking, we already kind of know, right? Allison saves $10 every week. So in my equation, this is where it's telling me how much we saved every week. So let's look at Allison's line on the graph compared to these other lines, and what do you notice about it, right? What did that 10 do? Well, if I'm looking at this, I can see that Allison's line is much, much steeper or going up faster than any of the other lines on the graph. So when I see a really steep line or a line that is increasing at a very quick rate, then I can also tell which person is saving the most. The other lines are not as steep as Allison's line. So let's write our answers in over here in our notes. What person starts with the most? That would be John. And the second number in the equation also tells me this, okay? And we can either highlight it in our notes or we can write it out. Okay, which person saves the most? Allison. How can I tell in the equation? First number. And how can I tell from the graph? Because it's steeper than the other graphs. It's going up. It's increasing faster than the other graphs were. The first number in my equation tells me how fast or how slow something is increasing. What happened here with John? Let's take a look at John's line over here. He wasn't saving any, right? So his line is not increasing at all. It's staying the same. It's flat. It's not decreasing. So it's staying the same. Okay. Whose bank account is going to reach $50 first? Well, again, you can pause the video and try and answer this question, but I think we already know, right? Allison's graph is going up very, very fast, and she's going to reach $50 first. Look, if I extend Allison's graph out, right, she's going to hit $50 at about 4.5 weeks. And so Allison, because her graph is so much steeper, she's going to be the first one to reach $50. Some lines are steeper than others. What does this represent? Well, steep lines represent higher increase or faster increase, faster or a higher increase, and bigger first numbers per, right? The bigger per part in the equation. If my number's bigger here, then I'm going to have a much steeper line, right? Try and answer in your own mind. This is going to be a question we answer later. What would happen if this number right here, my first number in my equation, what would my graph look like if that were a negative number? If this were a decreasing number instead of an increasing number? What do you think my graph would look like if I had a number that was negative there? That's going to be an answer to a question later on, but See if you can come up with something. All right, so let's go ahead and ask some more questions. Let's make some predictions. Predict how much money after each. Okay, so now we're going to use our equations to make predictions for the future. So our graph goes up to 10 weeks. We want to know how much savings will we have after 10 weeks. Let's start with John, right? He's not saving any money per week. How much money is he going to have at 10 weeks? Of course, he's only going to have $30 because he's not saving any, right? So let's use 10 weeks as our indicator. Now, here's the thing. Some of my graphs, right, actually go out to 10 weeks. How much money is Carrie going to have at 10 weeks? He's going to have how many dollars? Because I can look at my graph now and see that Carrie's going to have $45 at 10 weeks, right? That's what I think anyway. It looks like kind of like that's where the line is going to be. How can I know for sure? Well, I can use Carrie's equation, right, as a function in order to make predictions. So I can take Carrie's equation and I can check and make sure that my guess of $45 is accurate by using inputs, right, and outputs. If I input 10 weeks into here, what will my output be? Well, let's put a 10 in here and find out. 250 times 10 plus 20. And I can calculate it right in my calculator. 250 times 10 plus 20. And if I put it in my calculator, I get y equals $45. So I can see that I can use my graph to make a prediction, right? It looks like that's where my graph's going. Or I can use my equation to make a prediction. Some of these graphs don't go all the way out to, look at Bill out here. His graph doesn't go out to 10 weeks. But I could use my graph to make a guess, right? I could guess, but I don't want to guess. I want to be accurate. So we're going to use inputs to check and make sure. Now I can guess and see, right? And then check my guess with my actual calculation. So Bill's equation is y equals 5x plus 0. If I input a 10 into here, then I'm going to get out $50. Was that your guess? How'd you do? Okay. All right. So we can kind of get an estimate from our graph and then use our equation to be very accurate. All right. Now, Allison, she saves $10 per week. She starts out with $10. If my input here is a 10, right? 10 times 10 is going to be 100 plus 10 more is going to give Allison $110 in 10 weeks. Okay, then what about for a year? How could I predict a year? There's a couple of things that I have to be really careful about. Remember, my equation is in weeks. So if I'm going to predict for what they've saved in a year, then I have to change years. I can't just put a 1 in there. That's going to tell me 1 week, right? I have to change years to weeks. So how many weeks are in a year? 52 weeks in a year. So I always want to check and make sure that my labels, right, or my scenarios match my predictions over here. On your homework today, you're going to have to make sure that everything's matching up. And so you'll want to make sure that if you're making a prediction that you're using the right number to calculate for your prediction. So 52 weeks in a year. And so now my input is going to be 52. So I'm going to use my same equations, but this time my input is going to be 52 instead of 10. So I'm going to get 10 times 52 is 520 plus 10 more is going to be $530 over a year's time for Allison. And see how easy it is to make those predictions now that we have a good function that represents our savings. We can tell exactly how much, we can be pretty accurate with exactly how much each person is going to save, right? John, of course, he's not saving any money. So we can decide already he's only going to have his $30 in the bank. Bill didn't start out with any money, but he's saving $5 every week. So if we input our 52 into here, we are going to get $260, right? So his total savings is going to be $260. And then last of all, Carrie was saving $250 per week. So I can put my 52 in for number of weeks, right? And he started out with $20. And I can use my calculator to help me calculate the decimal. And $250 times 52 is $130 plus 20 more is going to be $150 saved for Carrie. So see how awesome those functions are? When I input, I can tell, I can use it to make predictions. That's how we do stuff with data in the real world. We come up with these equations, these functions that can help us make those predictions. Okay. All right. So we have one more thing that we have to do, and I'm going to go ahead and go back to, no, I don't want to. I want to go back to the split screen again. Okay, so now we want to know when people are the same. And I know this was a little bit challenging for some of you guys when we did this before, deciding when they're the same. I'm going to actually come back over to here, and I want to put this back up because we want to take a look at, I'm going to erase some of my writing on here. I want to take a look at these graphs again. And I'm going to erase some of my highlighting just so that it's a little bit easier to see. Okay, but I won't erase the labels. Here's Carrie. Here's John. And then Allison is over here. And let's see. Where did Bill go? Oh, Bill. Okay. All right. Okay, so I want to compare Allison and Bill. So here's Allison's line. Let's draw that in there. And here's Bill's line. Nope, that's Carrie. Was that Bill's line? He starts out at 0. Yes, that's Bill's line. So I want to compare Allison and Bill. Here's Bill, okay? And I want to know when they're the same, but when I'm looking at those graphs, I don't know. They kind of don't look like they're ever the same, right? They're kind of going on different tracks. And so I have to come up with a way to be able to find out when they're the same. And I know this was a little bit challenging for some of you when we did it before. Remember when we were trying to decide if the movie theater mug was worth it? This is the same thing. So I came up with a scenario where hopefully it will help you, kind of like the y equals blank x plus blank. Whatever I'm comparing Allison and Bill. I'm going to take Allison's equation. This is going to be Allison. And I'm going to write Allison's equation in this box right here. So Allison's equation was 10x plus 10. And then I'm going to do the same thing. This box is going to represent Bill. So whenever I want to compare two things, I'm going to use their equations to help me. And I'm kind of just taking off the y part. I'm stealing just the x parts from these equations from Allison and also from Bill. And I'm comparing these two equations, or I'm sticking them into these blank boxes and filling in for Allison, and then I'm filling in Bill's equation because I want to know when Allison's amount of savings is the same as Bill's amount of savings. So I'm taking their function and I'm comparing it. I'm comparing Allison's function with Bill's function. And then all I have to do is solve it like it's a regular old equation to solve. And this helps me figure out where they're the same. So remember, I have an x over here. And when I have an x on both sides of the equal sign, I want to choose one that I don't like and get rid of it. So I don't like these 5 x's over here, so I'm going to subtract them off. And that means I have to subtract from both sides in order to keep my equation equal. These two are going to go to 0. I have a 0 left over on this side. I have 5x plus 10 over here. And then this is my hostage situation on the left-hand side. I need to get rid of the extra hostage. So I'm going to subtract 10 from both sides. This is going to go to 0. 5x is equal to negative 10. And divide by 5 on both sides. And so x is going to be equal to negative 2. And that's weeks. Negative 2 weeks. What are we talking about? Well, really what's happening is Allison already started with more money, right, than Bill. And so if we extended these graphs out way back out here, they had the same amount, some at negative 2 weeks. So sometime before they even started saving, Allison had money. That's kind of what that's telling me. I know that doesn't make like total sense, but we also know the number of weeks that they are the same. So let's do another one and let's kind of see if we can see if this makes sense, if we can somehow make sense of this. Okay, so this time we're going to compare John and Allison. And so John is going to be over here in this box, and Allison is going to be over here in this box. John is saving $0. He started out with 30. Allison is our 10x plus 10. So I'm setting those two things equal to each other and then just solving for x, just like our regular equation solving that we were doing before. So this one, my 0 x's, right? Let's subtract them off, right? Subtract 0 x's from both sides. This is going to be 0, and I'm going to get 30 over on this side. And then this is going to be 10x plus 10. Then I have a hostage situation over on the right-hand side. So I'm going to subtract 10 from both sides to get rid of it. This is going to 0. 10x equals 20. And let me extend my page down here a little bit more. And divide by 10. X is equal to 2. 2 weeks, right? X is my number of weeks. So let's take a look and see if we can see something happening here, right? Let's see if we can see something happening here. Let's take a look at Allison and John. What is going on here at 2 weeks? what do you notice is going on at 2 weeks? That's where their lines cross each other. Okay, so now we can kind of go back in time and think about if I extended these down, these two lines are probably crossing down here at my -2 weeks when they had the same amount of money, right? And so what's happening when I have something that's the same on a graph is that it's a place where those two lines are crossing. They're the same at that spot. And if you'll notice, right, at 2 weeks, they both had $30. So that is the place where the amount of money that they had, $30, was the same. Allison had $30 there, and John had $30 there. Okay, so I hope you can kind of start to make connections on this. We are going to practice setting equations equal, and I want you to use this setup over here. Let's just kind of, whenever I'm comparing two different equations, right? And these are kind of abstract. You can come up with your own stories for these. But what we're really doing is just comparing two equations. We're trying to get used to figuring out when equations are the same. And so on your assignment today, we gave you some equations. And we said, what story could possibly represent these two equations? And so maybe I'm comparing a gym membership, right? A gym membership. Or maybe I'm comparing the cost of entrance fees for an amusement park. Okay, where one, I have to pay, right, $50 for my ticket, and then it's $5 per ride or something like that. I'm just going to kind of make up a story here. And then this one, it's only $5 for a ticket to get in, but then it's $5 to get in, and then $20 per ride. And I want to know when they're the same. And we're going to use this setup. So a good idea would be make sure and put a big star in your notes, right? You're comparing two things. Here I have two equations that I'm comparing, right? Is park number 1 better, or is park number 2 better? Or where would those two costs be the same? How many rides would I have to go on in order to get those two costs to be equal? And so I'm comparing equation number 1, and I'm going to fill in equation number 1 over here. And I'm going to compare it with equation number 2, which I'm going to fill in over here. And then once I have my comparison set up, I can just go ahead and solve it like I would solve any other regular equation. Oh, okay. So I subtract my 5 x's from both sides in order to get just one x, right? I want to get rid of any extra x's that I have first. And then I do my rewrite. And then I get rid of my extra hostage next. And then I divide by 15. And I get $3, right? Or whatever it was that I came up with for my scenario. But they are the same at x equals 3. So whatever my scenario would be, whatever I came up with for my story, right? Does that fit? So I'd have to go on 3 rides in order to make my cost be the same from the price of getting in. Okay, so you're on your assignment today. You're going to have 2 equations where you're going to just want to compare and solve and find out where they're the same. Let me make sure I've gone all the way through here on this. I just want to make sure. Okay, all right. Homework pickup problem for my kids in class. But if you have any questions, make sure that you email me or Mrs. Zeider or join one of our Google Meets. And good luck on your assignment.